MATLAB, or Matrix Laboratory, is a multi-paradigm numerical computing environment and proprietary programming language developed by MathWorks.com. MATLAB allows matrix multiplications, plotting of functions and data, implementation of algorithms, creation of user interfaces, and interfacing with programs written in other languages. An optional toolbox uses MuPad symbolic engine, allowing access to symbolic computing abilities. Previously, MATLAB used to have Maple's kernel embedded, giving access to Maple symbolic engine, but in the recent editions, MuPad symbolic engine is being used. An additional package called Simulink adds graphical multi-domain simulation and model-based design for dynamic and embedded systems. As of 2018, MATLAB has more than 3 million users worldwide, and MATLAB users come from various backgrounds of engineering, science, and economics, among other disciplines. MATLAB is acronym for Matrix Laboratory. So the first 3 letters of the word matrix and the first 3 letters of laboratory are combined together to form the word MATLAB. The official website of MATLAB is mathworks.com. MATLAB's latest edition is R2020A. R stands for release. 2020 is the current year, of course, and A is the first release of 2020. MathWorks releases 2 editions of MATLAB each year, the A edition and the B edition. So currently the A edition of the current year, 2020, is out. It is being designated R2020A. This is the website of MATLAB, the current website of MATLAB. So at mathworks.com, just go to mathworks.com and it opens up here in this location at products MATLAB HTML. Let's look at some basic commands of MATLAB. The clear command clears variables from the workspace. The who command lists the current variables in the command window. The whos command is the long form of who command. It lists the details of the variables, the sizes and the dimensions of the variables in the current workspace. The percentage sign is comment line in MATLAB. That is, whatever follows the percentage sign is treated as a comment in MATLAB programming. The ans is the default workspace variable. So the most recent output on the command window is returned to this variable if a variable name is already not assigned. So ans is the default workspace variable name. And the MATLAB command prompt looks like this with 2 arrows, arrowheads. So currently there are no variables in the command window. This is the MATLAB command window. I'm just showing the command window part. So if I say who, it returns nothing. So there is no variables active in the command window at this time. The whos, the long form of who, which gives the details of the variables, also returns nothing. There is no variables currently in the command window. The semicolon sign suppresses the output. So let's look at the way this works. An array, a row vector, is being defined here. A equals 1, 2, 3, 1, 2, 4, 5. And I use a semicolon next to the array definition. Then the output is suppressed. If I ask for the variable A, then it prints the variable as this row vector, as this array. So clear command clears the variables from the current workspace, the current command window. Another variable called B, another array is being defined here. Here I have not used the semicolon, so this definition, the variable definition itself, has printed the output onto the command window. So if I was using the semicolon, nothing was printed, the output was suppressed. If I'm not using the semicolon, the output is printed to the command window. So another definition, a 2 by 2 array is being defined here by using the semicolon operation. So when a semicolon is used, MATLAB pushes the data following the semicolon to the next row. So that 1, 2, semicolon 460 is the matrix 1, 2, 4, 60. It's a 2 by 2 matrix, which is returned to the variable A. This is the syntax, MATLAB syntax for creating 2 by 2 matrices. One of the MATLAB syntaxes for creating 2 by 2 matrices. The command zeros is a very convenient command. It allows creation of arrays with entries 0. The way this works is it takes argument of m and n of the size of the array with zeros. So zeros 5, 1 returns 5 by 1 vector, 5 by 1 array with zeros in it. Likewise, zeros 1, 3 returns 1 by 3 vector with 0 entries. So Z2 is the row vector 0, 0, 0 because it's defined to be 1 by 3, and the Z is a column vector of zeros of size 5 by 1. Random arrays may also be created by using the rand command. So rand takes 2 arguments. It can also take 3 arguments. Zeros also can take many arguments. We have multidimensional arrays and matrices. So here I've just taken a 2 by 2 matrix. I'm just creating a random 2 by 2 matrix using the rand command. So since I have not assigned a variable to this output of rand 2, 2, the MATLAB assigns the output of rand 2, 2 to the default variable name called ans. So rand 2, 2 is the random matrix with these entries. I'll talk about the random algorithms later. So ans is a matrix of size 2 by 2 with random entries. If we use a semicolon, the output of rand 2, 2 is suppressed. So here rand 3, 3 returns a matrix, a random array of size 3 by 3 with random entries in it. Another variable called A is a 1 by 2 row array. It's defined to be 1, 2. It's a row array of size 1 row, 2 columns. Its entries are 1 and 2. B is defined to be a row array of size 1 by 2 with entries 3 and 4. No semicolon is used, so MATLAB has printed the output to the command window, printed this assignment. Now, if C is defined to be this syntax, A followed by B, then this MATLAB concatenates the A and B arrays and creates a new array called C. Whenever this concatenation is feasible, that is, the A and B must be of concatenatable dimensions. They must be compatible. So here they're compatible because the row dimensions match. Rows are only 1. They match. So this concatenation is now possible. So C is concatenated as concatenation of A and B, and we have output 1, 2, 3, 4 assigned to the variable C. This is horizontal concatenation. Vertical concatenation is also possible in this case because the columns of both A and B are 2. So by using the semicolon operator, it is possible to create a D variable, D array, as vertical concatenation of A and B, giving you 1, 2, 3, 4 matrix, 2 by 2 array assigned to the D variable.